Alright, welcome to lesson 4.3. It's all about writing equations of parallel and perpendicular lines. Our opener in class that we're going to work on is this. You need to look at this, look at the 2 points, and figure out what they did wrong with making this point-slope equation based on these 2 points. I'm going to give 5 seconds here, and then I'm going to give the answer. Alright, so they did a few things right, but a few things wrong. First thing we want to look at is their slope. So did they do change in y over change in x? Which they did. They did y2 minus y1, gave 1. And then we have x2 minus x1, giving a 4 minus 1 is 3. So this portion is correct. Now as we go over here, we see they put in 2 and 4, meaning they would have had to use a point of 4, 2. However, that's not either of these points. So their issue was they didn't pick one of the points, they just combined the points. So they could have had two different answers. One answer they could have had was y minus 2 equals 1/3 times x minus 1. Or they could have had y minus 3 is equal to 1/3 times x minus 4. Those two would have matched the initial points. So today there are 3 learning targets. We're going to look on how do we talk about parallel lines, perpendicular lines, and then also some word problems. So we're going to start with parallel lines as they're a little bit simpler. Parallel lines are lines that have the same slope. They will never intersect, okay? And they are 2 non-vertical lines or parallel. Anything that is vertical is always going to be parallel because they're going straight up and down. 2 things that are going straight up and down are obviously not going to touch each other. So the slopes must be the same. So if we have a graph and we want to look at these, we have to figure out our slopes for all of these. As we have been doing, we could do some slope triangles. And for each one of these, this one goes down 1 over 1, 2, 3, 4, 5. This one for B is down 1, so that's the same, but this one goes over 4. And then the last one here goes down 1 over 5 as well. So the 2 lines that are parallel are A and C, as their slopes are the same. Alright, now we get into other problems. This one says write the equation of a line that passes through the point 5, negative 4 and is parallel to the line y equals 2x plus 3. Well, because it's 2x plus 3, and we know 2 is our slope, so right away in our new line we have our slope is 2. So we could start to plug in our new equation. Y equals 2 times x plus b. We don't know the b value, but we do have an x and a y up here on our new line. So we'd simply have to plug in our x and y values. So we would have negative 4 is equal to 2 times 5 plus b. We get negative 4 is equal to 10 plus b. Subtract the 10 to get rid of it, and we'd be left with negative 14 is equal to b. Therefore our new equation, so now once you have this and this and this, you can put them all together and they become y equals 2x minus 14. Just to recap, it was parallel, so we grabbed the same slopes. That's how we got this 2. This x value here and this y value here came from the initial point we were given. Once you have these points, you have one variable left for, so you're just solving down for that one variable, and then you plug in your m value and your b value into the actual equation. Perpendicular lines are lines that cross at a 90-degree angle. The biggest thing to note with these ones is that they must be negative reciprocals. So negative reciprocal means you are going to multiply, you're going to exchange the fraction, and you are going to change it from positive to negative or negative to positive. So this means we are doing negative, oh, don't need a highlighter. This would mean we would take whatever value we have, let's call it x, and we would times it by negative 1 over x, so we'd be flipping it around. Let's see what that looks like. So, sometimes you're going to have equations that are in different forms. This one is slope-intercept, this one is standard, this one is standard. It's probably easiest to get everything in slope-intercept so we know exactly what the slopes are. So for these two lines first, we need to change these to slope-intercept form. We've done this before. This one's going to become y equals negative 1/4 x plus 3/4. This one over here, again, we're going to get the y by itself, so we get negative 8 minus, negative 8 is equal to 2x plus 16. Divide everything by negative 8, so you'd be left with y is equal to 2 divided by negative 8 is negative 1/4 x plus 2. So when we look at these ones, we're looking for things that are negative reciprocals to each other. So one way to check for a negative reciprocal is, let's take our first equation. So 4 times negative, 4 is our x value. So when we do our reciprocal, we would do 1 over 4 and then make it a negative. So negative 1/4 is our perpendicular slope to positive 4, meaning that A and B are perpendicular and A and C are perpendicular. A and B, or B and C here, are actually parallel because they both have negative 1/4. Alright, let's continue on. This one says we know a point xy and we're looking for a perpendicular. So again, we're going to take our slope. So the slope here starts off as 1/2. We're now going to take the negative reciprocal of that, so we're going to do negative 1 over 1/2, which is equal to negative 2. So negative 2 is our slope for our perpendicular line. We now can plug in these x and y values, like we've done before, to get the rest of the equation for that perpendicular line. So we would start with y equals negative 2x plus b. We'd substitute in our x and y values, so we have 1 is equal to negative 2 times negative 3 plus b. This becomes 1 is equal to 6 plus b. Subtract the 6 over, so we get negative 5 is equal to b. Our new equation would become y equals negative 2x minus 5. Again, to recap, we knew the xy value from what they gave us, and we said it has to be perpendicular to this line. We start with a slope of 1/2, so we do 1 over 1/2 and multiply by negative to get negative 2 to be our perpendicular one. Essentially what you're doing is you're taking this fraction, you're exchanging the numbers, so it becomes 2 over 1, and then you multiply by negative, therefore it becomes negative 2. Then we plug it in to the base equation of slope-intercept form. We know the negative 2, we know the x and y values, we solve down for b, and then we put in the b value and the m value here. Alright, now we're going to address a word problem. So this word problem says the position of the helicopter is shown in the graph. So this is shown at the point 14,4. So we do have a point on this red line. We're looking for the line that is perpendicular to the shoreline. So this is the shore. We're looking to get the equation for this red line. That's really what this problem is saying. The problem is we don't have the points here, and if you notice the y-intercept isn't a clean y-intercept. But what we do have are the points right here and right here are given points, not labeled, but they do go straight through a lattice point. So this first point is 1, 3, and the second point is 4, 1. Meaning we can use those points to find a slope, grab the perpendicular of that slope, and then substitute into our equation. So we have 2 points. If we find that change in y, change in x, we would simply have our slope here would be a change of down 2 over 3. If we're going to take the negative reciprocal, our new slope will be positive 3 over 2 because we flip it and we multiply by negative, and negative times negative is positive. So again, this is our original, this is our green one, and this is our slope for our red line. Well, now that we have the slope and we have the points of an xy point here, we can plug that into our base equation. So y equals 3/2 x plus b, plug in 4, plug in 14 plus b. 14 times 3/2 is 21. You can always check in a calc if you're like, Mr. M, how'd you figure that out so fast? And then we subtract the 21, so we'd be left with b is equal to negative 17. Therefore, our new equation for the red line is y equals 3/2 x minus 17. So that's your homework for today. Good luck. Have fun.